Everybody, it's Mrs. Wolf. I'm sure that you're bored by now and probably looking for some math problems to do, so I thought I would help you out. I've heard from a few of you about the literal equations. Do those the best you can. I'll try to get some keys out to you so that you can check some things. Today we're going to do everybody's favorite kind of math problem, story problems. And Avery tells me that you all have seen the work rate problems before, so hopefully those won't be too much of a big deal. If you're taking notes, today would be Thursday, March, I don't know, 19th. Today's the first day of spring, you guys. Go outside and see if you can find some flowers sprouting up. I'll bet you can. The grass around our house is greening up, so I think that we've got good things to come, all right? Okay, so the work rate problems, I have a worksheet that if we were at school I would have given you that have the problems on them for notes. I asked Avery if I should take a picture and send it to you or if I should just work right off the paper. I think I'm just going to go ahead and work right off the paper, so hopefully you guys can see it okay. These problems usually have 2 or 3 or 4 people and they're all trying to work together to get a job done. What I tend to do when I'm doing these problems, and I'm going to ask you guys to do, is figure out what you've got. So I've got Liza and I have David, and so I write those things off to the side so I can kind of keep track of what I've got going on. Now, Liza can paint the kitchen in 5 hours. That means that she can do 1/5 of a job in 1 hour. David, you're told, can paint the kitchen in 3 hours, which means that he could do 1/3 of a job in an hour. He works faster, obviously, than Liza does. If they work together, how long will it take to paint the kitchen? The work together time is what you're going to multiply each of these by. And because we don't know what the work together time is, you're going to call that X. The equation in this instance is if Liza and David work together, so that would be the sum of their work, would equal 1 whole job done. Now, this goes back to the stuff that we did in the last chapter where you have to get common denominators and solve for X. You can write it like this. You could also rewrite the same problem like this if you prefer, and I think sometimes that kids think it's easier to do a common denominator like this. Common denominator in this case is 15. Whatever you multiply one side of the equation by, you have to multiply the other by. So right here would be 3x, 15 times x over 3 would be 5x, and 1 times 15 is 15. We end up with 8x equals 15, x equals 15/8, which is 1 7/8. What that means is it takes Liza 5 hours to do a job, David 3 hours to do a job. If they work together, they can get it done in 1 7/8 hours. Now, we could convert that 7/8 to minutes if we wanted to by multiplying by 60, but since we're all at home in our kitchens and dining rooms and bedrooms and wherever, I'm not going to be too picky about what your answers look like. Backside. Oh, I bled through. Look at that, you guys, down here. All right, the next one. Rodney and Tommaso, I'm guessing is how you say his name. Obviously, I didn't write this worksheet. Can build a cabinet together in 12 hours. So again, I would ask you to kind of keep track of some stuff over here. And remember we said that this is how long it takes them to work together? Well, we know that it takes them 12 hours to work together. We know that Rodney by himself can build the cabinet in 16 hours. So he would get 1/16 of the job done in 1 hour. Tommaso, there's the question. We don't know. We put the X there. Again, Rodney and Tommaso added together will give you 1 whole job. So there's your equation. Now you can multiply 1/16 times 12, and that's going to give you 12/16, and 12/16 will reduce to what, 3/4? So that's 3/4. This I can rewrite as 12 over x, and this I can rewrite as 1. Common denominator between these two fractions is 4x, so multiply everything on both sides by the common denominator. This denominator is missing the x, so that becomes a 3x. This denominator is missing the 4, so 4 times 12 is 48, and 1 times 4x is 4x. And this problem ends up being x equals 48. How long would it take Tommaso to build the cabinet alone? It would take him 48 hours to build it by himself. Okay? Now, down here you've got 3 things going. You've got pipe A, pipe B, and pipe C. Or actually pipe A, pipe B, and a drain pipe. We didn't call the drain pipe pipe C. And this is where I bled through down here, so hopefully you guys can see. An Olympic-sized pool can be filled by pipe A in 18 hours and pipe B in 12 hours. There is also a drain pipe that drains the entire pool in 8 hours. If the valves for all of them are left open, how long would it take to fill the pool? What you need to understand here is water's coming in pipe A and pipe B, but that drain pipe was left open, and so water's going to come out of that. So you have two things added together, and you're subtracting the drain pipe. So pipe A, 1/18, pipe B, 1/8, and the drain pipe is, oh, no, that should be 1/12, shouldn't it, you guys? And then the drain pipe is 1/8. This is what we're looking for, how long if all of them are working together. So what we're going to end up with here is x over 18 plus x over 12 minus x over 8 equals 1 whole job. Common denominator between 18, 12, and 8 is 72. So if we multiply through here, we get 4x, 12 goes into 72 6 times, so that's 6x, 8 goes into 72 9 times, so that's 9x, and over here we have 72. This will be 10x minus 9x, x equals 72. 72 hours because all of our units were in hours. So if water's flowing in pipe A and pipe B and it's flowing out of the drain pipe in 3 days, the pool will still be completely full even though that drain pipe is open. I'm going to attach 3 worksheets. You will probably not hear from me tomorrow. I'm hoping, I still have back issues going on and that kind of thing, so I'm hoping to be back with you guys on Monday and you'll hear from me then. Send me pictures of fun stuff you're doing. It's getting kind of boring around here, so I'd like to see your faces. Hope everybody's doing well, and we'll talk to you soon. Bye, guys.